Hello students, come to the next lecture of continuous random variable. So what is given in this question? Let's see now. If the probability density of a random variable is given by f of x equal to k of 1 minus x square for 0 less than x less than 1, 0 otherwise. Find the value of k and probabilities that a random variable having this probabilities density will take on a value number 1 between 0.1 and 0.2, number 2 greater than 0.5. Okay, so this is about the this is the given question. Let's discuss briefly about the given function f of x. See, this f of x have a two function. One of function is k of 1 minus x square and one more function is 0. And this k of 1 minus x square, can I say, will be existed when the values of x is from 0 to 1. Then when this f of x equal to 0 will be happen? That is my question. Can anyone guess? See, f of x equal to k of 1 minus x square will be happen at 0 to 1. Then when will be happen this f of x equal to 0? Because in the question he mentioned otherwise. So otherwise in the sense, can I say except 0 to 1, except 0 to 1 in minus infinity to plus infinity. I think everyone is understand when this f of x equal to 0 will happen. Right, let's discuss. This will be happen at minus infinity to 0 and 1 to plus infinity. See, whenever x values between these two, then your f of x is 0. When x values are between 0 to 1, then this will be your f of x. I think everyone is clear to you, right? So now we'll find the value of k first of all, then we'll go to the rest of the two questions. Okay, right? Okay, see, he wanted to find a value of k. So whenever he wanted to find a value of k in this continuous random variable, we had to take the help of second property of continuous random variable. I hope we seen in the discrete random variable also. At that time he wanted to find a value of some variable. So at that time we are taking the help of second property of discrete random variable. What is the formula of the discrete random variable? Summation p of x equal to 1. So this is the second property of discrete random variable. So what will be the second property of continuous random variable? Integration minus infinity to plus infinity f of x dx equal to 1. This is the second property of continuous random variable. So my question belongs to continuous random variable, right? So that's what I will take the help of second property of continuous random variable. Okay, right. So we know that we know that integration minus infinity to plus infinity f of x dx equal to 1. Okay, right. Now if you observe to this formula containing the limits are minus infinity to plus infinity, right? So my question, at these limit, does he given the value of f of x? No, right? He given, but he split it and given f of x. So how I'm writing, let's see. See, this integration minus infinity to infinity, I'm splitting by using integral by parts. Integration minus infinity to 0, this one I written. f of x dx plus integration 0 to 1, this one I written now, f of x dx equal to dx plus integration 1 to infinity f of x dx, it is equal to 1 now. I hope everyone is clear to you. This concept we are having in the intermediate, and the topic name, this content will call it as integral by parts. I'll give you the exam formula for this. We have in the intermediate integration a to b f of x dx, and for this we are written integration a to c f of x dx plus integration c to b f of x dx we written. See which of upper limit become a lower limit here. So similarly, this is upper limit and here is lower limit, and which of upper limit, here is lower limit. So I can write that minus infinity to plus infinity, here a to b. Okay, so this concept I implemented to this my present question. Why? Because can anyone guess what is the reason to write like this? Hmm? Because f of x value we did not given directly between minus infinity to plus infinity. This is the reason to splitting my given formula. Okay, right. So minus integration minus infinity to 0, right? I have to write here f of x value. So at this limit minus infinity to 0, what is the value of f of x? Tell me. 0. 0 is a value between, when x value is between minus infinity to 0, right? So 0 dx plus integration 0 to 1. At these limits, what will be the value of f of x? See, at 0 to 1 your function is k into 1 minus x square, right? So k into 1 minus x square into dx plus when see integration 1 to infinity. So at these limits, what is the value of f of x? We have a value from 1 to infinity, f of x is 0. So I substitute here 0 into dx equal to 1. So next, now integration of 0 is 0 plus, here k is constant, so keeping it outside, integration 0 to 1, 1 minus x square, I'm keeping it as it is, I'm not changing anything, plus again integration of 0 is 0 dx, 0 equal to 1. So which implies what how I'm going to solving this. Let's see. So k of I'm taking this integration inside of both the terms. Okay, so I can write it as integration 0 to 1 1 dx plus minus integration 0 to 1 x square dx, it is equal to 1. Is it correct everyone? Right. So later on I'm substituting the formula of this answer. Okay, so k of integration 0 to 1 1 dx plus integration 0 to 1, what I'm having, x square, no, actually I'm having here is minus, so minus x square dx is equal to 1. Okay, so which I written as it is without any changes. Okay, now k of integration of 1 dx, what is the formula for this? We have in the intermediate, that is integration a dx is equal to a into x is my formula. Okay, Now come to the second, for second one, we have a formula. Integration x square dx is equal to x power n plus 1 by n plus 1. So these are my formulas for first one and second one, right? So now we'll substitute here. So integration of a into dx become a into x, right? So here a is nothing but 1. I think no need to write. So x and the limits are 0 to 1 minus integration of x square dx x power 2 plus 1 by 2 plus 1, which means x power 3 by 3, and the limits are 0 to 1. It is equal to 1. Okay, so now k of substituting upper limit minus lower limit, 1 minus 0 minus of 1 cube by 3 minus 0 cube by 3 and bracket close equal to 1. Okay, see what happened here. Here only x I'm having, so in the place of x substitute upper limit minus lower limit. Here I'm having x power 3, right? So upper limit power 3 by 3 minus lower limit power 3 by 3 I substituted. So next step, k of 1 minus 0 is 1 minus 1 power 3 become 1 by 3 and minus 0 power 3 by 3 become 0. So I'm getting value 1 by 3 here is equal to 1. So k of, by taking LCM, 3 minus 1, 2 by 3 is equal to 1. So therefore k equal to 3 by 2 is my solution. Hence we found a value of k. So what I did here, whenever I want to find a value of k in the continuous random variable, I should take the help of this second property, continuous random variable. Okay, integration minus infinity to plus infinity f of x dx equal to 1. This formula help I should take it, then I can find a value k. Okay, if my question is belongs to the discrete random variable, then I have to take the help of summation p of x is equal to 1. Then we can get a value of the constant in the discrete random variable. I hope everyone is clear to you, right? So in this question, asking to find a value between 0 0.1 and 0 0.2, and one more asking to find greater than 0 0.5. Okay, so let's solve those two also, right? So come to the first question, between 0 0.1 and 0 0.2. So can I write p of 0 0.1 less than x less than 0 0.2, and it can be denoted as integration 0 0.1 to 0 0.2 f of x dx, right? Integration 0 0.1 to 0 0.2, at these limits, what is the value of this f of x? As for my question, let's see, x values are from 0 0.1 to 0 0.2. Is x values from 0 0.1 to 0 0.2 is there in 0 to 1, or is there minus infinity to 0, or is there from 1 to infinity? Tell me. 0 0.1 to 0 0.2 is there in this function 0 to 1, right? So that is my the value of f of x. So I'm going to writing it k into 1 minus x square into dx. Okay, so now doing an integration, first of all, taking k is constant outside, k of integration 0 0.1 to 0 0.2 of 1 minus x square into dx. Now keeping k as it is, this integration I'm taking inside of both the terms 1 and x square. So it will become integration 0.1 to 0.2 1 dx minus integration 0.1 to 0.2 x square dx. Now integration 1 dx is x from here, x, and the limits are 0.1 to 0.2 minus integration of x square from this formula x power 3 by 3, and the limits are 0.1 to 0.2 bracket close. Now substituting upper limit minus lower limit, 0.2 minus 0.1 minus, okay. Now here also open the bracket. Now substituting upper limit, 0.2 whole cube by 3 minus 0.1 whole cube by 3 bracket close, and we have a value of k here, right, which is 3 by 2. So let me substitute here only 3 by 2, and now this entire values I'm substituting in the calci and getting the result is 0.2965. See, this is the probability between 0.1 and 0.2. Integration 0.1 to 0.2 f of x dx is equal to 0.2965. Okay, right. So we'll see the one more question. I mean, that is the second one. So that is asking you to find greater than 0.5. Yes. So how can I denote the greater than 0.5? P of x greater than 0.5. Am I correct? Right. So it is equal to integration 0.5 to, so what are the values of x here? 0.5 to infinity. So integration 0.5 to infinity f of x dx will be happen, right? So in the last question, at 0.1 and 0.2, I asked you one question. At the limit 0.1 to 0.2, what is the function f of x? Then we see k of 1 minus x square. And similarly, come to the present question, 0.5 to infinity, right? So do you have a function f of x from 0.5 to infinity? No, right? We have f of x from 0 to 1 and 1 to infinity, as well as minus infinity to 0. So what I'm doing, that given second question, I'm splitting by using integral by parts. Okay, so integration 0.5 to 1 I'm splitting f of x dx plus integration 1 to infinity f of x dx. Okay, so at these limits, what is the value of f of x? As for my question, 0.5 to 1 k into 1 minus x square dx is the value of f of x. Let's see. Yes. Yes or no? So now plus integration 1 to infinity. So at these limits, when x values are 1 to infinity, what is the value of f of x? Tell me. 1 to infinity. See, 1 to infinity is here. So f of x is 0. F of x is 0. So I can write here 0 into dx. So next step, k keeping it outside, k of integration 0.5 to 1 minus x square dx. Now we know the value of k in the last question, 3 by 2 we had. So 3 by 2 of integration now taking inside of the two terms, so it will become 0.521 1 dx minus integration 0.5 to 1 x square dx. Next, 3 by 2 of integration of 1 dx is x and the limits are 0.5 to 1 minus integration of x square become x cube by 3 0.5 to 1. Okay, right. So now 3 by 2 of substituting upper limit 1 minus lower limit 0.5 minus, now substituting upper limit 1 means 1 cube by 3 minus lower limit 0.5 0.5 by 3 whole cube bracket close main bracket close. Now what is the value by substituting in the calci, right? So by I'm getting the solution 0.3125. Okay, so this is the value of integration 0.12 0.52 infinity f of x dx. I hope everyone is clear to you. So this is the second lecture of continuous random variable.